Hi, today we'll be looking to implement a simple game called Snake. We'll be using HTML, JavaScript and CSS. The aim of the game is to run around the grid collecting the apples. You use the arrow keys to change the direction of the snake, and you need to avoid running into the side of the grid or into the snake's own tail. If you run into either the side of the grid or the snake's own tail, that ends the game. And just for the simple game, we'll make it so that to restart the game, you have to refresh the page. So the version of Snake we'll be programming will follow the same rules as the one released on the Nokia 3210. This was released back in 1999 and shipped 160 million units. Given it only had 3 games on it, it probably makes Snake one of the most played games of that era. I'll include a link in the comments below to where you can play a version of this game. This video is going to be aimed at those quite new to programming, so you'll need to know some very basic HTML, CSS and a bit of JavaScript. We'll be coding the game using Visual Studio's Code. VS Code is a free IDE developed by Microsoft, and if you don't already have it, you can download it. Type VS Code into Google, and then you can download it from codes.visualstudios.com. It's available on Windows, Linux and Mac, and there's not going to be anything in this tutorial which is platform specific. One of the things I'll be looking to do during this tutorial is to build things up very slowly and incrementally. So we'll start off with the very basics, and we'll take almost baby steps throughout the process to get to our end game. In reality, this is how most professional programming is done anyway. We don't always know what our end code is going to look like. We always break the problems down into lots of small steps and tackle them one by one. So with all that said, let's get coding. So to start with, let's create a folder someplace on your computer. I'm just going to create a folder called snake_game on my desktop. After that, open up Visual Studio's Code, go to the Explorer tab and click Open Folder. We then find our folder that we've just created and point VS Code at it. Now VS Code is pointing at our folder. We can create files in the Explorer section, such as index.html, and they will appear in the folder that we pointed VS Code at. Now that we've got our index.html file, let's populate it with some content. So we'll give it a doc type of HTML, then a HTML tag. Within that HTML tag, a head tag, and beneath that head tag, a body. In the head tag, we'll put a title of Snake, and in the body, we'll put a h1 of Snake game. After that, we can go up to File and then click Save, or we can use Command S to quickly save that file. Now that that's saved, we can go to our original folder, right click and go to open with, then open with one of the browsers on your computer. I'm going to use Google Chrome. You can see that Chrome opens up the file on my computer. You can see in the URL bar that it's pointing to the local file on my computer, not a remote web page. We can see the title in the tab section at the top, and we can see the h1 tag at the top of the page. Now we want to add a section to the page where we can put our snake game. Let's add a div and give it an ID of board. And then we also need to add some styling to it. So we'll add a style tag in the head section. We'll pick out the div with the board ID by doing #board. And then within that, we'll give it a background color of grey. We'll give it a width of 500 pixels and a height of 500 pixels. Save that, then refresh our web page. We can see that the div appears. Now that we've got our board, we'll want to populate it with lots of cells that our snake can run around in. To do that, we're going to make the board div have a display of grid. We're also going to define a grid template for columns, and we're going to have that as repeat 12 times 1fr, and we're going to do similar for rows as well. This will make our board be a grid of 12 by 12. To add cells to the board, we'll put divs within the board section. I'll just start out with 3 in there, and then add some styling for them. So in the style section, we'll identify those divs as anything that is a child of board, which is also a div, and we'll give that a border of black, 1 pixel and dotted. So if we save that and refresh this page, we'll see that our first 3 divs appear in the top left-hand corner of the board. Because we've made the board 12 by 12, if we wanted to fully populate the board with these squares, we would need to add 144 of them in there. The divs will fill up the grid as we add more, going across the top of the screen first, and then as it fills in a complete row, we'll then get more rows filled in as we add more. As we can see, just adding lots and lots of divs in here makes it quite hard to maintain the page. So instead we'll want to do this programmatically. To do that, we'll delete these for now, and beneath our div, we'll add a script section where we can write some JavaScript. At the top of the script section, we'll grab hold of the board div that we had by using document board.querySelector. Within that, we'll pass in the same thing that we used in our CSS to identify our element, so hash board. After that, we'll do board.inHTML, we'll make that equal to a string with our divs in it, and we'll also close the div, and we want to repeat that string 144 times. So we save that and refresh the page. We'll see that it fully fills in the grid. We'll add in a couple of constants at the top of the page to make it easier in the future to change the number of rows and columns that we have. So we'll have a const for width and a const for height. We'll set those both to be 12 for now, and then we'll make it so that our repeat uses those two constants. Now, in the future, if we wanted to change the number of rows and columns, we could change the values here, perhaps to 16 by 16, and also here, 16 by 16. Save, refresh the page, and we've now got lots more squares in our grid. Let's change it back to 12. At the moment in our index.html, we've got HTML content, we've got CSS content, and we've got JavaScript content. We ideally want to split these out into separate files to make everything more manageable. So we'll start with splitting the CSS out. We'll create a new file called styles.css. We'll copy across the CSS content, and then we'll replace our style tag at the top with a link instead. We'll give it a href that points at the styles.css file, and we'll give it a relationship of style sheet. Save that, refresh and check it's still working. We'll do similar for our JavaScript. We'll create a new file called main.js. We'll copy across our JavaScript code, and then we'll replace the contents of the script by just pointing it at the source file. It will just point and take the contents of main.js now. If we save and refresh that page, we see that we get the exact same thing as we had before, but now the content is split between 3 different files. Now that we have a grid displaying it as a web page, the next thing we want to be able to do is make certain squares within the grid change colour. This will allow us to represent the snake moving across the grid and also the apple that the snake will eat to grow. To do that, we will pick out certain divs within the grid and give them a new class name. Let's say we want to highlight the first of the 144 divs that we have in our grid. To do that, we'll do board.children, which will give us an array of all of the divs within our grid, and we'll get the first element. We'll then do classList.add, and we'll add a new class name of snake. If we then go to our styles.css and add a .snake and give that a new background color of green, we save and refresh, we'll see that our first element, our first div of the 144 is now highlighted. If we wanted to highlight the last div, that would be the last element in the array, which in our case would be 143. Let's refresh and see that that is also highlighted. To calculate which index we use to highlight any of the other cells within the grid, we need to count how many cells have come before it. And the way we'll do that is kind of take the y index of it and times that by the width of the grid and add on the x index. So for example, if we wanted to highlight the 5th cell across and the 5th one down, we would say let x equal 4, let y equal 4, and then we could get the appropriate div by doing board.child, and then within there we would say width times by y plus x, and then we'd add the class name for that. Save, refresh, and you can see that we've highlighted the 5th one across and the 5th down. Again, the reason why we use 4 for that is that they're 0 indexed, so we're counting the very first element in the top left to be x of 0, y of 0, and the one right in the bottom right to be x of 11, y of 11. Now that we've looked at how we can highlight individual cells, how might we go about highlighting multiple cells together? So let's delete the existing code for now, and let's have a think about how we would want to represent a snake on the grid at any point in time. So we would need an x value and a y value for each cell that the snake was on. So what we can do is let snake equal an array, and then within that array we'll have multiple objects, each with an x property and a y property. So if we have a snake of 0, 0, 1, 0 and 2, 0, that would be the top left, the one next to it, and the one next to that. To draw that snake, we would need to loop through the snake array and draw each cell individually. So to do that, we'd use a for each, and then we would write a bit of code for each cell. So we'd say let x equals cell.x, let y equals cell.y, and then we'd essentially do the same code that we had before, which is board, children, and then grab the value based on the x and y. So width times y plus x, get the class list, and add the class name of the snake. So if we refresh the page, we can see that we've drawn out the values specified in the snake. And if we changed, for example, all the y values to 4, this will move the snake down to here. And if we change the x values to 3, 4, and 5, it will move the snake across. Now that we're able to display a grid and draw a snake on it, the next thing we'll want to do is be able to move the snake. So the simplest thing that we can probably do is to have the snake move across the board towards the right. Eventually that will be driven by a time-based mechanic, so every X number of milliseconds the snake will move. But whilst we're developing the game, we might want to have more control over it. So for now, what we'll do is make it so that every time the user presses the space bar on the web page, the snake will move. To do that, we need to implement the onKeyDown function. OnKeyDown will give us a keyboard event. And for now, let's just look at what the keyboard event actually gives us. So if we save that, if in our browsers we go to More Tools and we open up Developer Tools and we go to the Console tab, if we refresh the page and press the space button, we'll be able to see what that keyboard event is. So by pressing the space bar whilst on the web page, it triggers this code here. We can see the keyboard event is an object and it's got lots of properties. Most of them we don't need. All we really care about is what this code value is. We can also say if we press some other buttons, such as the arrow buttons, we get different keyboard events for each of those, and they have different codes. For now, we're just interested if the user presses the space key. So we'll say let code equals keyboard event.code, and then we'll add an if statement for if the code equals space, then we will want to move the snake. To move the snake, we'll implement a function called step. So within the step function, we'll want to do two main tasks. We'll want to update the state of the game, and we'll then, after we've updated the state of the game, we'll want to redraw the UI. So we'll add in functions for those as well. In terms of redrawing the UI, that will be taking the code that we've already done for drawing the snake. We also need to take this code that completely resets the contents of the board.inner.html. So every time we redraw the UI, we completely reset the board divs, and then we draw the snake onto the grid. Because we've moved that to a function, we need to make sure that we also call that function at the start when we first load the page. In terms of update state, we need to now decide how we're going to do that. So what we want to happen when this snake moves towards the right side of the grid is we effectively want to add a new cell at the top of the snake. So let's call it 6-4. And we refresh that, we'll see that we get an additional cell added to the right. And we would also want to get rid of this last cell, because that would get rid of that one. So those two steps will effectively move the snake towards the right. So if we started there, if we add a new object at the end and get rid of the first one, we move our snake over one. So we need to figure out how we will do that programmatically. So the first step is going to be to figure out what the cell that we're going to move to will be. So in our case, we need to figure out what the existing head of the snake is. So I'm going to say in our implementation, whatever is the last object in the snake array is going to be the head of our snake. So in update state, we'll get the current head, and that will be the last element in the snake array. We get that by looking for the index of snake length -1. Once we've got the current head, and because we're currently saying the snake can only move towards the right hand side of the board, it's quite easy to figure out what the next head indexes will be. It will be the values of the current head, but will increment the x value by 1. So let's define next head to be an object where the x value is current head.x plus 1, and the y value is just a copy of the current head. We can then use snake.push to add the next head onto the end of the existing array, and we can also use snake.shift to remove the first element from the snake. So if we save that, refresh the page, and press space a few times, we'll see that the snake moves across the page. Let's review what we've done so far. We can now press the space button to move the snake across the grid towards the right hand side. To do this, we intercept the keystroke in the onKeyDown function. This calls the step function. In the step function we call update state. Update state will update the contents of the snake array. It does this by calculating the current head of the snake, figuring out what the next head will be, and then pushing that next head onto the end of the array and removing the first element in the array. After updating the state of the array, we then need to redraw the UI. This is done by completely resetting what is in the board div. So it will be 144 clean divs without any class names set on them. And then after that, we loop through the snake array, and for each cell in the snake array, we pick out the appropriate div and we set it to have a class name of snake. This results in its background color changing. Those color changes are set up in the styles.css, and our index.html is what links everything together by bringing in the styles.css and the main.js. Alright, we're kind of at our first breakpoint now. We've got our HTML and CSS set up with a bit of JavaScript. If you want to take a look at the code as it is at the moment, I'll put separate links in the description below so that you can see how the code is at this first breakpoint. Let's continue coding our snake game. The next bit of functionality we want to add in is for the ability for the snake to change directions. To do that, we need to detect when various arrow keys are pressed by the user. So we'll go down to the onKeyDown function and we'll figure out how we want to detect the arrow keys. Let's change our console log to print out the code rather than the entire keyboard event. Let's save that, refresh the page, then have a look at what happens when we press the arrow buttons on the page. We can see down here that the keyboard event codes that we get for the various arrow keys are arrow up, arrow left, arrow right, and arrow down. What we want to happen when the user presses these buttons is to change some variable. Let's go back up to where our snake is defined at the top, and we'll define a new variable, this time called direction. And we'll initially set this to be the right. So by default, the snake will move towards the right when the game starts. Now that we've set this direction variable, we can add some code in here to change that direction when the user presses the various arrow keys. So if code equals arrow up, then we'll set the direction to equal up. We'll do similar for the other directions. So arrow down will equal down, arrow left will result in the direction being left, and arrow right will equal right. Now that the direction variable is changed when the various arrow buttons are set, we need to update our update state logic to reflect the fact that the snake can be moving in different directions. So we need to update the logic in update state to make use of this direction variable. So we'll initially always set next head to be the exact same as current head, and then we'll have some if statements below it which deal with the direction. So if direction equals up, we'll say that the next head's y value is decremented. The reason we do this is because if the snake is traveling up, the y value is heading towards 0. For down, we'll say that the y value is incremented. And then for the left, it is going to be the x value that is decremented. And for right, the x value that's incremented. Let's save that and refresh. And now if I press the space button, the snake is moving towards the right. If I press the down arrow, the snake starts moving downwards. And if I press the left arrow to the left and up, it goes upwards. So we now have a snake which can move around the grid. Whilst the snake can move around the grid, as we expect, it can also do some certain things that we don't want it to be able to do. For example, it can go back on itself. So if we start moving towards the right, and then we press the left arrow key, the snake actually does a complete 180 and moves back over itself. We don't want it to be able to do this. To stop it doing this, we need to keep track of what its previous direction was. So we'll add a variable for previous direction. We'll initially set that to be an empty string. In update state, the first thing we'll do is set the previous direction to be equal to the direction that was set. And now in our onKeyDown function, we can ignore arrow presses if they are in the opposite direction to where the snake is currently going. So if the user presses the up arrow and the snake is currently traveling down, we should ignore that. The way we'll do that is by saying and previous direction does not equal down. Let's do that for the other directions. Save that, refresh the page, and now we can check that the snake cannot do 180-degree turns. Now that we can move our snake around the board, we want to be able to have the snake eat apples and grow in length. To do that, we need to define where the apple will be on our board. So we'll create a new variable, we'll call it apple, and we'll give it an x and a y value. In our redraw UI function, we now need to display the apple on the board. So we'll add a new section to the redraw UI where we draw our apple. It will be similar code to how we draw each cell in the snake, but instead of using the x and y from the snake, we'll use the x and y from the apple. And rather than setting the class name to be snake, we'll set it to be apple. And then in styles.css, we need to add a new thing to define what an apple should look like. For now, we'll just set it to have a background color of red. Now we can refresh the page and we can see that our apple appears on the grid. Now let's have a look what happens if our snake goes over our apple. At the moment, it doesn't do anything. What we want to happen when the snake goes over the apple is for the snake to grow by a cell and for the apple to be placed someplace else on the grid. To achieve that, we're going to have to update our update state function. Our update state function currently calculates the next head value of the snake based on the direction the snake is traveling in. So for example, if we move the snake around to be about to hit into the apple, then it will, because it's traveling to the left, it will calculate that the next head is going to be on this square. What we want to do is check if this square is where the apple currently is. So we'll write an if statement down here and we'll say if next head dot x is equal to apple dot x and next head dot y is the same as the apple's y location, then we know that we are eating the apple. Regardless of if we eat the apple or not, we always want to push the next head onto the top of the snake. However, we only want to remove the first element from the snake array if we're not eating the apple. So we'll add an else statement. So if we're not eating the apple, we end up removing the first element. But if we are eating the apple, we won't. So this means in the event that we are eating the apple, we add a new element to the end of the array, but don't remove one from the start of the array, and therefore the array will grow by one, and our snake will be one bigger. The other thing we'd like to do when we eat the apple is to increment a score. So at the moment we don't have anything defined to track a score, so we'll go back to where we're storing our variables for the state and we'll introduce a score. And then in our if statement we can increment the score by 1. And now we're also going to need to add something into our HTML to display the score. So in our index.html beneath our h1 tag, we'll add a paragraph where we can show the score. We'll do a score, then we'll do a span, and we'll give it an ID of score-span, and then initially it will just be set to 0. Let's refresh that and see what it looks like. Back in our JavaScript code, we'll want to be able to grab hold of that span and change its contents. So similar to how we got hold of the board, we'll grab hold of a score span by using the query selector. Now in redraw UI, as well as drawing the snake and drawing the apple, we can update the score. We'll do that by setting the text content to be the same as the score. Let's refresh our web page and see what we get now. When our snake travels around and moves over the apple, you can see that the score increments and that the snake grows one larger. But we also need to make it so the apple moves whenever we eat it. We'll go back up to update state, and we'll add in here that we need to move the apple. Rather than write the code in here, we'll define a new function to do that. So we'll have a function called relocate apple. Let's define that function down here. So what do we want relocate apple to do? It needs to generate a new location for our apple. So we're going to need an x and a y coordinate. And the x and y value is going to be a random place on the grid. So for our x coordinate, it needs to be a random number between 0 and 11. And for our y coordinate, it also needs to be a random number between 0 and 11. And these things might need to change in future based on our width and height values. So moving down to relocate apple, how do we get a random number between 0 and 11? So to start with, we can use math.random, and that will generate a random decimal number between 0 and 1, e.g. a long string of random digits. If we then want to convert that to be a random number between 0 and 11, we then need to multiply that by our width value. So math.random times width, that's then going to give us a random number between 0 and 11, but it will be a decimal number. So we want to take that random number and we just want to remove the decimals off the end of it. So to do that, we'll use math.floor. So we'll do math.floor, and then inside that, we'll take our math.random multiplied by our width. So that will give us a random whole number between 0 and 11. So we would say we want apple to equal new object where the x value is going to be this math.floor times by random times by width. Our y value will be exactly the same, but we'll be setting the y value and using height instead. Let's refresh the page and see what happens now when our snake eats an apple. It randomly moves the apple to someplace else on the grid. We can also make it so that rather than the apple always being placed at 2, at the start, we always place it in a random location. So when we first create a new game, we'll randomize where the apple is located. Now every time we refresh and get a new game, the apple moves its location. If we do this many times, we might see an issue. The apple can randomly relocate itself onto the top of the snake, and we want to be able to avoid this. So let's go back to our relocate apple function, and we need to modify our code to stop it from being in any cell that our snake currently occupies. The way we'll do that is to just, after we've randomly picked a cell for our apple, we'll check if it intersects the snake at all, and if it does, we'll just randomly pick another cell, and we'll keep doing that until we get a cell that isn't on the snake. So to check if the apple is located on the snake, we would need some code that something like this would say, for the snake, which is currently an array of cells, we would ask if some cell exists where cell.x is equal to apple.x and cell.y is equal to apple.y. So if this sum comes back as true, we know that the apple has ended up landing on top of the snake. And in that case, we would want to rerun this code here. So there's a few different ways that we could do this. The one that I'm going to pick for now is just to recall the relocate apple function. This then ends up making the relocate apple function being a recursive function. It will keep calling itself until it finds a location that isn't on top of the snake. You could also do something like a do while with similar code. Let's refresh the web page and check that we never end up on top of the snake now. So I've rerun that a fair few times and it seems to be working. So our snake can now move around the board. We can eat apples, which will then relocate to another cell on the board. And it can also grow in length and grow in score. The next thing for us to think about are the cases where the game will end. For example, if our snake runs into the side of the grid or our snake runs into its own tail, then the game should end at that point. Because at the moment, the snake can just continue running around. To deal with the game ending, then we're going to introduce a new bit of state, and it's going to be just called game state. And initially, it will be set to running. If the game ends, then we'll set this to over, and we'll block the step function from doing anything. So in update state, after we've calculated the next head location, we need to figure out if the game should end or not. So the first thing we'll check for is if the snake runs off the edge of the screen in this direction. At the moment, if it goes over the right-hand side of the screen, it just carries on the next line. To check for that, we'll say if nextHead.x is greater than or equal to width, then the game should be over. If the game is over, we don't want to run any of the code down here, so we'll put that into an else block. In the if statement section, we will end the game by setting the game state to be over. And then in our on key down thing, we'll block the space button doing anything. So if the user presses space and the game state is running, we'll allow step to be called. Otherwise, we won't allow step to be called. So if we refresh our page now, and we just keep pressing the space bar to run our snake to the right hand side of the screen, at this point, the snake will stop doing anything. And essentially the game will effectively be over until the user refreshes the page. Let's go back up to our update state code, and we need to do similar for our other directions. So if nextHead.x is greater than or equal to the width, so if it equaled 12 and was off the right hand side, then that's going to end the game. But if it ends up being to the left hand side of the grid, that means the x value is going to be less than 0. So we'll add an or statement here, and if nextHead.x is less than 0, we also want the game to be over. Let's save that, refresh that, and just check that when we run the snake to the left hand side, that also ends the game. We'll then do similar for the y values, going either below the height of the grid or less than 0 above the grid. So if the y value is greater than or equal to the height, or the y value is less than 0, that should also end the game. Let's refresh that and test it out. So that ends the game there, and this ends the game here. The final thing that should end the game is if the snake runs into itself. So I've just set it up so we've got quite a long state now, so that I can demo that. At this point, the snake shouldn't be able to run to its own tail like that. That should have ended the game. To calculate if that is the scenario, we're going to do something very similar to what we did for calculating if the apple ended up randomly placing itself on top of the snake. We're going to check if any of the cells currently in the snake match the next head that we've calculated. So to do that, we'll add another or, and we'll say that if snake.sum, and then we'll check if any cell in snake matches the next head. So cell.x equals nextHead.x, and cell.y is the same as nextHead.y. Let's refresh that. I'll reset up that scenario so that we can test it again. Okay, I've got a reasonably sized snake now. So at this point, if I press the space bar at this point, the next head would be this location here, which is running over the top of an existing snake cell, and that should end the game. So if I press space, we see that the snake stops moving at that point. With that, we've actually implemented all the game logic that we need. All the rules of the snake game are now implemented. What we've not done is made the snake game run based on a time interval. At the moment, it's all based on the user input pressing the space button lots and lots of times. So now we want to introduce that time interval so that it actually plays like a game of Snake. To do this, we're going to slightly modify our game state. So initially, rather than being running, we're going to set it to ready. And it's going to be ultimately in one of three states. It'll either be ready, then it'll go into running, in which case we will keep every X number of milliseconds taking steps, or it'll be over. So it initially starts out as ready, and the thing that's going to trigger it to start is the user pressing any button on their keyboard. So let's go to our onKeyDown function. We can get rid of where we previously had the space button, because that's no longer going to trigger our code to run. Instead, we'll say that if any keyboard button is pressed, if the game state is ready, then we'll start the game. So we'll have a new function for starting the game. So let's write that start function. So function start. So the first thing the start function is going to do is change the game state to be running. After that, it's going to use setTimeout, and it's going to call the step function after a short delay. This will result in our step function being called after 300 milliseconds. If we then go up to our step function, in our step function, after updating the state and redrawing the UI, we also then need to decide if we need to queue up another step function if our game is still running. To do that, we'll just quickly check the game state, and if it is equal to running, we'll do another setTimeout of calling itself, so calling step after 300 milliseconds. Let's refresh the page, and now if we press any keyboard button, our snake starts moving by itself and keeps moving every 300 milliseconds until the game ends. Let's set that timeout value that we've set in our code to be defined at the top as part of our state. I might also move the start function up to be next to the step one, as they're quite closely related. Finally, we'll also make it so that this timeout interval shortens every time you eat an apple. This makes the game progressively harder. So in the same place that we increment the score and relocate the apple, we'll make the snake move faster by decreasing the time interval. To do that, we'll just set it to be 90% of its existing value by multiplying it by 0.9. We can also increase the starting difficulty by reducing this number. So let's maybe knock that down to 180. Let's refresh that. Now when I press any key, it should be a much harder game. By the time we actually get our score up to around 10, it actually becomes quite challenging to keep the snake on the grid. So with that, we've actually implemented our snake game. For the rest of the video, we'll focus on styling it to make it look better, but we won't add any more functionality. Okay, so at this point, let's recap what we've got. We've got a fully functioning snake game. In terms of the initial state, we've got the initial position of the snake. We've got the direction that the snake initially starts traveling in. We've got the previous direction that will update so that we can avoid the snake moving back over itself. We've got a variable for the apple, which will get set in relocate apple. We've got a score, which will be incremented every time we eat an apple. We've got some very basic game states. So the game can either be ready to play, it can be running, or it can be over. And we've got a timeout interval, which sets the initial timeout for when we start playing the game, and that will gradually decrease as we increase our score. The game will initially kick off in the onKeyDown function. So if the game state isn't ready and the user presses any input, that will kick off the start function. Within the start function, if we head back up, that changes the game state to be running, and then we call a timeout so that the step function runs after our initial timeout interval. The step function then updates the state, so it will try and move the snake around. It will then redraw the UI after the updated state, and then if the game is still running, it will trigger itself to be run again in an appropriate amount of time. So that kind of is the fundamental loop that our game is in whilst it's running. Then the update state function, we calculate our next head position. We see if that is going to end the game or not. So if the next head ends up being off the board or the snake running into itself, then we just set the game state to be over. If the game isn't over, then we will push the new snake head onto the snake array. We'll figure out whether or not we're eating an apple, in which case we'll increment the score and relocate the apple at that point, and also decrease the timeout interval so that the snake speeds up. And if we're not eating an apple, then we remove the first element in the snake array, which effectively, because we added one and then removed one, keeps the snake the same size. In redraw UI, so this gets run after we've updated the state, we completely reset the board to be 140 clear divs without any class names. We run through the snake array and set the class names for those cells to be snake. We find where our apple is located and find the appropriate div and set a class name for that div to be apple so that we can colour it in red. And finally, we update the text content of the score span so that the score is updated whenever we eat an apple. The relocate apple function gets called whenever we've actually eaten an apple and also when the game first runs. It will look to randomly pick a square on the grid and place the apple there. It then checks if that location is not on a cell that's currently occupied by a snake. And if it does happen to be unfortunate and locate itself on top of the snake, it recalls this function so that this code runs again. So all in all, for the entire JavaScript part of the snake game, it's just 130 lines of code. In the index.html, again, we've hardly added anything since we began. All we've got is a header. We've got a paragraph that will represent the score, and then we've got a div, which is where we've placed our snake board in there. And then we also point at the main.js, so that which is where our game code lives. And we also link to the styles.css, which tells us how to display the various elements that are in our page. So we tell the board how to lay out a grid, at the moment a 12 by 12 grid. We then say how any child divs of that board should be displayed. So that is the outlines of each individual cell is a dotted black line. We then say for any div that happens to be given the class name of snake, it should be coloured green. And if it's the apple or has the class name apple, it should have a background colour of red. Alright, so we've reached breakpoint 2. We now have a fully functioning snake game. If you want to take a look at the code as it is at the moment, again, I'll put links in the description below and a breakpoint 2 for where the code is at the moment. The rest of the tutorial is just going to add more styling on top of what we've already got. It's just to give you an idea of how you might make the page a bit more colourful. Now that we've got a functioning game, let's add some styling to it to make it look better. Go to styles.css. First, we'll center the contents of the body. Let's add a section for the body. Set the display to be flex. Set flex direction to column. And then align item to center. Refresh the page and you can see that the contents of the body has all been centered. The h1 tag, the paragraph, and the board div. Next, we'll add a background for the entire body. We'll put in a background image of a conic gradient. And then to make that fit the entire window, we'll put in a size of cover, repeat of no repeat, position of fixed. We'll add a width and a height to the body to cover the entire screen. And finally, we'll set a margin of 0 pixels as well. If we refresh that, then we get our conic gradient covering the entire background. Now that we've styled the background, let's add some styling to the board itself. Let's change the background colour to mint cream. We'll add some opacity so that we can see the background image behind it. Change the width and height to 70 v min. The board will now grow and shrink based on the size of the window. We'll also want to style the heading and paragraph text so it fits in with the background colour. So we'll give the H1 a new colour, font family and size. And then we'll do similar for the paragraph. Let's refresh that. Now both the size of the board and the size of the text will change with the window size. Next, let's look at changing the apple from a red square to an actual image of an apple. To start with, I found an image of a small apple online. Let's copy that into our folder. So we can see that appears next to our index.html, main.js and styles.css files. To get it to appear on our board, we're going to put an image tag within the div that represents the apple. So because we're now going to have divs within the individual cells that represent each div, we're going to make it so that each of those is display type flex. We'll go to main.js and go down to our redraw UI function. In the place where we're going to place our apple, we'll create a new image tag. To do that, we use create element and pass in the image string. We'll give that a class name of apple. We'll then also point it at our image picture. So we'll set the source to equal apple.png. And then rather than setting the class name on the child div of the board, we'll instead append the image tag that we just created. So the class name now applies to the image tag rather than the div from the board. We want to style the image tag by telling it to be flex grow of 1. So it takes up the entire cell. And then also to set the image's width and height to be 100% of the cell size. So we save those things and refresh the page. We see that our red square now turns into an image of an apple. We're also going to want to change the snake cells themselves from being green squares to circles with multiple colours. To do this, we'll add new divs within each individual cell div and then set those divs to have a circular border and a background colour based on a hue, saturation and lightness value. So we've got to main.js, and where we style the snake cells, for each cell we're going to create a new inner div. So use document, create element, div. We'll set the inner div to have a class name of snake. We're going to give that inner div a new background colour by setting the style.background colour to equal a HSL value. For example, 300, 100%, 71%. We'll then append that inner div to the actual cell on the board in a similar way that we did for the apple. So when we refresh that, the snake's not showing at the moment. We'll have to make some additional changes in here. So we need to set our snake class name now, because it's the inner div, to fill up the size of the cell. We're setting the background colour programmatically, so we can get rid of that. We're also going to give it a border of 1 pixel black solid, and we're going to give it a border radius of 50%. So that's a circle. Let's refresh that. We'll also want to set programmatically the margin of each circle as a percentage of the cell size. So if I set that to 20%, we can see that each circle's got a much larger margin there and takes up less of the cell. To get different colours for each part of the snake and different sizes for each part of the snake, we're going to programmatically change the hue value in the HSL colour and the margin value based on the index of the cell within the snake array. So snake itself is an array with multiple objects. So to set different hues based on the index, we need to pass in the index to the actual for each function. We'll let the hue value equal the index multiplied by 27. This will give us a gradual change in the colours throughout the colour wheel. We then use string interpolation to put that into this string. Let's refresh that, and we see that we get different colours for each different segment of the snake. We'll also want to set the margin programmatically so that as we move towards the head of the snake, the circles get larger. So to get our desired margin, we'll calculate that based on the index as well. So it'll be the snake length minus the index, and we want to multiply that by 2 to get what percentage we want for the margin. So if our snake actually grows too long and our snake length gets too high, then our margin will become larger than 50% and we'll no longer be able to see the circle. So we want to cap this value at something like 32. So we use math.min to do that. I'll just wrap all this, make sure that the margin value never goes over 32. Now again, we can use string interpolation to add our percentage side onto the end of this. So change the double quotes to backticks, use the dollar brackets to insert our numeric value into this string. If we refresh that, we'll see that we've got the head of the snake is always almost all of the full circle. And then as our snake grows, the tail of the snake should become smaller and smaller circles. All right, so I've allowed my snake to grow to the size of 15. You can then open the developer tools and inspect these different elements to see how big the margins actually are. So the head of the snake has got a margin of 2%, which is what we'd expect, because the largest index will always end up being 1 smaller than the snake length, and therefore 1 times 2 would be 2%. As we go down our snake, so we select the next one along, we get 4%, and that keeps going down until we get near the end of the snake, where we get 30%, and then 32%, and then it sticks at 32% after that. Finally, if we want our colours to change every time that we run this code, we could set an initial hue value based on a random number. So we'll go up to the top of our main.js, we'll go const hue seed equals, and again we'll use our math.floor. Inside that, math.random. We'll times that by 360 to give us an initial hue value. We can then add that in front of our index times 27. That means every time we refresh the page, we'll get different starting colours for our hue values. So that gives us our completed game. Right, that's it. End of the video. Well done if you got this far. Hopefully you enjoyed it and found it useful. If you did, let us know in the comments below or give the video a like. I would much appreciate it. Again, just a reminder that if you want to look at any of the code, whether or not at breakpoint 1, breakpoint 2, or the completed code, that'll be in links in the description as well. Cheers and have a good day.